Hello, everyone. Good evening. The topic for today's discussion is going to be ensemble learning, and it is so we are learning this topic to understand what random forest is. So, first of all, like my apologies for gap of these few weeks in between the videos. So let's continue on our track, machine introduction to machine learning. So like today, so this is a very important topic, and we'll be looking at what ensemble learning is, and what are the ways in which we can do ensemble learning, and what is random forest. So a random forest is also a type of ensemble learning. So to start with, so what is ensemble learning? So ensemble means a group of certain things or certain ways or certain methods, right? So ensemble signifies a group. When you look at a complete group, not just an individual. Okay, so let's start with ensemble learning. So suppose we want to buy a laptop for us, and the way it is, you go to shops, you ask about like what are the price of a laptop, what are the different features of the laptop, and you buy a laptop, right? So this is one way of buying a laptop, or a normal way that everybody follows. But what is more involved in this process is that some part of research, you apply certain strategies. Okay, you ask for opinions from your friends, right? And you also go for go to different shops before buying any specific laptop or the model of the laptop that you want. And you also look for reviews online. Okay, so basically what you are doing is you are gathering different informations, different feedbacks from different shops, from different platforms, like online, visiting different shops, from different buyers or different companies like Dell, Lenovo, Acer. Right. So what do you want? You want to build a certain model which can give you relationship, which can explain the relationship between like what are the features of the laptop that you want, and finally which brand you should go for, or which laptop you should go for. Right. And the same model should be able to explain any new, should be able to map any new input to a predicted output. Okay. So if this is the RAM and this is the performance I want and this much is the memory, then which laptop I should go for. Right. So uh, basically, while applying these strategies of looking for reviews online, then visiting shops of different vendors, and asking your friends about their opinions, and taking into account all of their decisions, what you are applying is called ensemble learning. Okay, so basically you are applying a group of different strategies to come at a final solution or final prediction which laptop to buy. Okay, so if your friend is using a Lenovo laptop for years, he will only prefer you. There is very much high probability that he will refer you a Lenovo laptop. If one of your gamer friends is using the new Asus Republic of Gamer series laptop and he's very happy with that, he will refer you that. If you go to different shops, then the shop owners will try to pitch you a laptop which of their own company. Like if they are they have a dealership of Lenovo, they will pitch you a laptop, or the laptop of Lenovo. If they have a dealership of Dell, they will pitch you a laptop of Dell, right? But based on all of this information, and based on the reviews that you read, and based on your own requirement and your own budget, you have to finally come at a solution or a final answer that okay, I'm going to buy this laptop of this much is the price, and this is the feature that I want. Right. So this is like a whole sole point of ensemble learning, where you are applying a group of different strategies, or do a group of different methods to arrive at a solution. Okay. So basically, like to put it in a very like in the machine learning terminology, you are having multiple hypotheses, right? So H1, H2, H3, H4 are different hypotheses. Hypothesis, you can think of hypothesis as some different approaches or different strategies. Okay, so like this hypothesis says Lenovo laptops are best. This hypothesis says Dell laptops with this much of RAM is best. This hypothesis says something else. This hypothesis says like go for the laptops which give you what maybe which have a very good support, or which have customer service, very good customer service. So when you like for the same training set, So it is my training set. I have multiple data points, and in the same data point, I'm using different strategies. Like maybe in this example, I'm using four different strategies to come at a prediction. And at the end, I'm combining the output from all these four different strategies or different methods to finally make a prediction. Right? It is called ensemble learning, or it's an ensemble method, which is more like an aggregate hypothesis. Right? So this one, this H, considers the output from all the different individual hypotheses. Right? So why are we using this? So why, before buying a laptop, I am going to ask all of my friends about their reviews. I'm visiting number of like 5 to 10 shops physically, and I'm also reading outputs. I'm also reading reviews online. All this is done is all like we do before buying a laptop is done to reduce any kind of error or any kind of mistake, any kind of false claim that I should not fall into, or any kind of bias, if you can think of, right? So like any kind of modeling bias in terms of machine learning. So if my data, suppose my data is biased, right? So so I should not get any particular I should not get an output which is like biased towards certain results. Okay, so suppose I'm talking about a classification of picture of between cats and dogs, and if my model contains, or if my training data contains 99 pictures of dogs and one picture of cat, so for every picture it should not tell it is a dog, right? So my data should can have may have some errors. The hypothesis or the model that, or the strategy that I'm using, may have some error, right? So I may go to a friend who is like very much biased towards Lenovo laptop, so he will only refer Lenovo laptop. So maybe it is not suitable for my budget or for my use, right? And if I go ask my gamer friend, he will refer me a very, maybe a probably a very costly laptop which I may not require. So it's always better to look at a combined result of multiple strategies, multiple methods, which help us to improve the error rate and overcome the modeling bias, right? So like how can I achieve this kind of ensemble method, right? So there are different ways in which I can uh, uh, apply ensemble method. One like, so like the training data is one big training data. I can divide the training data. I can use different modeling algorithms, like somewhere I can use decision trees, somewhere I can use logistic regression, somewhere I can use linear and multiple regression, and some other way I can use support vector machines, right? And I can combine their output in all different forms. I can use some weighted average methods. So there are different ways in which I can perform this ensemble learning. Okay, so it is like I can define, okay, so if I'm visiting 5 physical shops, so one should be of Lenovo, one should be of Dell, one should be of Acer. So I should give equal importance to all the dealership and see their exact actual recommendations and their reviews. And I should go for like Amazon, Flipkart, and all the other online e-commerce websites which are selling laptops. I should read all the reviews, not just the good 5-star reviews, but the 3 stars and the 1-star reviews also. And also I should ask all of my friends. I mean, I should not ask only those friends who are like gamers and who are using like laptop just for watching movies. So if my requirement for buying a laptop is for like, I need to perform some I need to like make some presentations, I need to watch movies, I need to do some a bit of the coding also, I need for video editing, I need to make some graphics on maybe like Adobe Photoshop and all that. So I should consider all of these points, right? So I should talk to all of the friends who are using laptop for different purposes, not just a gamer friend and a friend who is just using for watching movies, because their reviews and their recommendations, their suggestions can be biased, right? So what are the different ways? So very first way of performing ensemble learning can be different model algorithms. Okay, so like based on the same training data, I am like, for first model, like the very first strategy can be a decision tree, the second strategy can be a support vector machine, then the third strategy can be a linear regression or multiple regression or neural networks. So this is one way, like for the same data set I am applying different modeling algorithms to give me an output, right? Second strategy can be to change the parameters within the model. Okay, so suppose for the say I'm using decision trees for all different base models. Like, so these individual models are called base models, right? So I'm using decision tree with there is some like certain number of trees. I am limiting the model parameters. Model parameters are like what is the number of number of nodes that I'm using, what is the branching factor, and what should be the depth of the tree. So I can vary the parameters within the same model to obtain different results, so that it overcomes all kind of shortcomings of the training data. All kind the variance of the data is considered. The inbound error and biases are also considered. So second method is changing the parameter within the model. Third method is changing the training record. Okay, so basically, changing the training record means like, so I have this much of this big of training data, so I can build model on I can build several base models using some subset of this data. Like this, on this data, in this part I'm making this model. On this particular data, using this training data, I'm making this model. Using this particular data, I'm making this third model. So using the subset, dividing my training data randomly into different parts, and then modeling uh, and modeling just on those small parts, I can get a better combination of outputs and suggestions and recommendations. Okay, so I can divide my training data into multiple sets, and each set can be used to build one of these base models. Right, this is the third strategy. The fourth strategy that can be used is changing the attribute set. Okay, so we are talking about the types of conditions to change the base model. So here base model are these individual models which contribute to the final uh, ensemble of all ensemble learning method, right? So the fourth one is the changing the attribute set. So attribute are the features. So for my laptop, it's the RAM, it's the hard disk space, it's the like Windows, like whether I want Windows or I want Linux, and then whether I want graphic card or not, whether like it should be touch screen or not. So these are the features or the attributes, like based on what is the price, right? So all these 5 6 things are my attributes or features on which I have to make a decision which laptop to buy. So one other, like the other way of using ensemble learning is to divide the data set in based on attributes. Suppose these are my all of my attributes. So one of my model can contain just these three attributes. Other model can contain only these four attributes, and the last one, the one other separate base model can contain only these three models, right? So this is like why one of my models is giving me suggestions based on the price, the RAM, right? And the other, this model is giving me the suggestion of laptop to buy on based on what is the hard disk space and which Windows are you using. And this particular model is giving me suggestions based on whether it is touchscreen or not, whether it comes with a graphic card or not, right? So I'm dividing the features into small groups and using those features to build a model and make a prediction, right? So and like finally, once I have after applying these one of these four strategies or a combination of those four strategies, I can train my different models. Like I can make my different base models, then I will ask them to make a prediction. Okay, which laptop should I buy? So this says Lenovo, this says Lenovo, and this says Dell. Then after, like there will be multiple models like 10 20 30 whatever, depending on my situation or my condition, I can use as many models as I want. So then at finally, I should use a vote model. So like Lenovo got 2 votes and this one got Dell got 1 vote. So finally, my answer or my final prediction should be Lenovo. So like basically, Ensemble most popular way of arriving at a final prediction is using the voting, by using voting. So whichever prediction, whichever class gets more number of votes, or whichever like the class or that particular laptop model which gets predicted by most of the base models, I should go for that particular laptop, right? Now comes the concept of bootstrap aggregating or bagging. Okay, so now bagging is a technique where base models are developed by changing the training set for every base model. Okay, so suppose this is my training data and it has n records are there. Now I want to create m base models I want to create out of this n training data records. So how can I do that? So like I will create M record. These T are the training sets or the trainings or the subsets of the training set of each individual base model. So like each of these model will contain n records but with replacement. Okay, so like each of these T1, T2, T3 up to Tm will contain n records only, but with replacement. So there will be number of repetitions in each. There are possible repetitions in each of these training sets, right? So the disparities, the errors, the biases of the training's data gets dispersed. Okay, so like there are few data points which will never come in this particular training data set sample, and there are some features which will not come in this one, and there are some features which will not come into this particular training set, and eventually will not be a part of this particular model. So by making multiple of these base models, by using training data set sampling by replacement, we are eliminating those errors which were like inbuilt in the training data set, like biases, like some outliers, or maybe some very strong correlation between the features. All those is being taken care of by using this method of bootstrapping. So this method of dividing the data set into smaller subsets by allowing sampling with replacement. So this is a term which is important: sampling with replacement. So like the number of records in each of the subset of training data will be same as the training data, but they will be sampled with replacement. Okay, and the aggregating is the step where we take where we make the final prediction based on the voting model. Okay, so we take predictions from each of the base models, and whichever output or whichever laptop in our case gets the highest number of votes. Okay, I should go for a Lenovo laptop of this model. We should select, we should go for that particular laptop, whichever laptop gets the highest number of votes, or whichever laptop model gets predicted by the most number of models, most number of base models. So this step of choosing the final prediction based on the vote is called aggregating, and the step of selecting or doing random sampling with replacement for the base models is called bootstrapping. So when you combine both of these, this whole thing is called bagging. Okay, so bootstrap aggregating is called bagging. So like bootstrap aggregating, you add the b of this and aggregating the ag of this, you get bagging. Okay, it's an important term. So it is just like dividing, doing random sampling with replacement, then using the vote model to go for the final prediction is called bagging, right? So we can we should use bagging when we have enough number of data set. Like when I have a huge data set, and I want, like, suppose my data records contain thousands and lakhs of records, and I want to make like hundreds of these sub models, right? Base models. I want 100 sub models to go for a prediction, right? So this is very popularly used where my data is huge, like Flipkart, maybe Amazon. So all of these big companies where the data flow is really huge, they use bagging or bootstrap aggregating, right? Next term in ensemble learning is called boosting, right? So boosting is a just to give you a very informal example. So like when you are playing any team sport, maybe football or cricket or basketball. So whenever like you are at the worst, like you want to win a game, you are losing right now. So what do? You motivate your teammates. You try to boost their confidence by telling them, okay, they are playing really good, they can do this, we got this, we are better, that we are a better team. So the same thing when you apply to a training record is called boosting. So suppose this is my initial training record, and based on this I'm making a model 1, and it is making some predictions, right? And because like anything in this world, any training data or any machine learning model is not perfect. So it will make some errors, it will do some wrong classification, it will make some wrong predictions, right? So but what now we can do is like for those data points which for which my model is giving me wrong predictions, I can increase their weight in the sense like they will have higher chances of getting selected in the next sampling task, in the next sampling. So the whole concept of boosting is we start with the training data, we build a model, then we make some predictions, then I will have right predictions and I will have wrong predictions. Then for the data points for which I got wrong predictions, I will increase their weight in the training data, right? So the for those, like suppose I have I want to make a classifier which of pictures, so which will tell me like whether it is a dog or a cat, right? Just a picture classifier, two things I want to get. So suppose in one of my with my starting data set, training data set, I get very wrong predictions about cat pictures. So in the next sampling in the model 2, I will take more pictures of cat and less picture of dogs. So I will increase the weight of cat pictures. Okay, so now in this sample I will have more pictures of cats and like less picture of dogs. So here I will make less error in predicting the cat pictures because I have more cat data. Maybe like I was having less cat data in this first round, but in the next model it is like solved. Right now I will have, suppose I will again, like after this model 2 also, on this prediction also I will have some errors, right? Some right predictions, some wrong predictions. So again, for the wrong predictions, I will increase the weight and feed it to the next sampling stage, and I will again make a model with the new sampling. Here also, I will have make some right predictions and wrong predictions, and I will like keep on doing this until and unless I am making very less errors. So it kinds of it will combines many weak learners. So these are weak learners because they are making some errors. So I'm combining these weak learners and boosting them till a point where they are making very good predictions, and I'm getting very less errors. So this is called boosting, right? So finally I combine all of these models to get a combined base model, right? So this is what I tried to explain before. So like same thing, I have a training sample, then I make a model, I make my predictions. These predictions I keep these predictions, then I assign weights, then I and feed that those assigned weights as the training data to the next model. I make some prediction based on that, then I again do check whether I right predictions or wrong predictions. Then based on my predictions, I again assign weights, again train a third model and make some predictions. And finally, for the output, I combine my predictions from all of these individual models to get a better result. Right now, like coming to the main reason why we have to go through this ensemble learning is random forest. So what is random forest? So like let's try to understand the name first. So like forest is simple, it's a collection of trees. Like forest we is a place which have a lot of trees and animals, right? And random means like there is no, like, so there is no, not of, you don't see a forest of mango trees, forest of people trees, forest of eucalyptus trees. Forest is means like randomly you can find trees, and trees of all kinds, long, tall, short, thick, heavy, light, right? All kinds of trees you will find. And random means like there is no order, right? If you go to a forest, there is no order. You can find trees in any random order, in any different density. There is, you cannot predict, okay, a forest has to be like this. It's not a garden, it's a forest, right? So random forest means a random collection of different trees, right? So if you understand this thing, like a random forest is a collection of different type of trees, right? A group of randomly distributed trees, then you understand what is the concept of random forest in machine learning. It is the same thing, right? So what we do is we use the technique called bagging, though the like the same thing we discussed few slides back. So this is my training data. I will make a subset of this training data, right? I will make multiple of the subsets. Then I will, on each of the subset, I will make a decision tree. I will make a decision tree for this subset, for this subset. I will use different decision trees for each of these models, right? So for individual subsets of my data containing the same records, I will perform decision tree analysis and make some prediction, right? Make some prediction, I will combine all of these predictions to come at a final prediction, right? So basically it is using for the same data, training data set, you divide the data into multiple parts, and for each of the parts, which is a base model, you apply a decision tree and come at a prediction. So like this is like I talk to my friends. This is my first strategy. I will talk to my friends. After combining all of the friends, this conclusion, my prediction is go for a Dell laptop. This is after doing online survey, right? Combining all the things, all the points which I got from an online reviews like Amazon or Flipkart. I got go for a Lenovo laptop, and this is like when I visited different shops, and based on their their answers, I decided to go for a Dell laptop, right? So similarly, I'm making like all of them, I'm using the process of decision trees only, but my data, my training data is a subset of the main training data, right? So I'm using some of the features, some of the a subset of the main training data, and I'm making predictions using decision trees. That's why it is called a random forest. So this is also a tree, this is also a tree, this is also a tree. I am using multiple of these randomly distributed trees to come at a final prediction. That's why this whole thing is called decision tree, right? So how to do that? So basically, there are two things that we do in a random forest. First of all, I will select some and training records, right? We are not we are So this is my complete data, training data. I am using just n records with some like selected with replacement, random selection with replacement. I am making m records out of this training data set. Each of them contains n data points, right? Then I'm not using all the features. I'm just using a certain set of features to make predictions. Okay, suppose this decision tree is using RAM and hard disk. This is using processor and graphics card, right? This thing is using what should be the Windows, like Linux, or maybe go for Apple OS, right? Or what should be the uh, like there has to be a fingerprint sensor or not, or what is the price. So I'm not using all the features in all of these base models. I'm using some features in this decision tree, some features in this decision tree, some features in this decision tree to come at a prediction, right? So all the so my the small the trees, the decision trees that are going to be the part of my random forest, they are a subset of the training data and the feature, right? So like some of the features, some of the data is in this tree, some of the features and some of the data is in this tree, some of the features and some of the data is in this tree, and based on this particular subset of training data and subset of features, I will make one prediction, right? So basically I will n random sample is selected with replacement, then a number d is selected where d is less than m determines the number of attributes to be considered for node splitting. So basically these are the features that you want to use for node splitting. Next, the third step is a decision tree is started for each node. Instead of considering all the m attributes for the best split, a random number d is attribute are considered. I will not go for all the 6-7 features that I want that I'm looking for. One decision tree will take into account 2 features. The next one will take into account 3 features or 3 attributes. Next one will take into account like 2 attributes, right? And based on that, we'll make a prediction, and I will choose the by voting method which laptop to buy or which prediction should be my final prediction. This is what the whole concept of random forest is, right? So just to summarize, to improve the performance, we can use many trees with a random sample of features chosen as the split. Okay, so like, and we have try to recall the trees. Like each node is a attribute on which we will perform a split, right? So a new random sample of features is chosen for every single tree at every single split. Okay, so for classification, m is typically chosen to be the square root of p. Okay, so basically so p is my total number of features. So basically, like, I will choose only m features, which is the square root of p, right? So suppose I have around like 15 or 16 features. So I will typically, every decision tree will use only 4 features, which is the square root of p, right? Now, like, what is the point of doing this? Suppose there is a very strong feature. For our example, the price of the laptop becomes very important, right? So like, you want 8 GB RAM, 1 TB hard disk, then you want graphic card, and you want touch screen also, and your budget is 25,000. Then of course you are not going to buy. You will not find any laptop. Okay, so like, for our laptop buying example, the price becomes a very strong feature. So if your price is 25,000, then all those choices, all that 8 GB RAM or Windows 10, your graphic card, touch screen, all is no point. You cannot buy that. Your prediction will always be no. You cannot buy this laptop. Okay. So similarly, if there is a very strong feature in the data set, right, which is capable of giving you the very ultimate split, or that very pure split, like we discussed in the decision trees, then that particular feature is going to affect all of my like my decision process, right? So when we are using bagged trees, most of the trees will use this particular feature as the top split, because like it will have the lowest entropy, then of course it will do the top split. But and it will result in an ensemble of trees that are highly correlated, right? So if I'm using all the features, suppose I'm using all the features, then this particular strong feature will be used by all the models, and all the models will be like use this particular feature to do the top split because it is very highly correlated. So all of my trees are going to give me more or less the same result. But now since we are not even if you average the highly correlated quantities, it will not reduce the variance, like that effect will still be there. But since we are not using all the features in all the trees, we are just using, so if there are 10 features, I'm just using 3 features for each decision tree, right? So like there will be trees which will not contain that very strong feature, right? So it will give me a different result. So using this strategy of not using all the features in each of the decision trees, I am allowing the random forest to decorrelate the trees, right? So that I get a more holistic, more complete prediction, not any biased or any should not. It takes care of that variance. It takes care of that bias which was caused by that one particular highly correlated feature, highly very strong feature. That's why we are using just a subset of features and a subset of samples, training samples. Right. So let's just look at the steps that needs to be followed. So we will, like at random, we will use k data points. I can use like k data points, or you can use same number of data points with sample with replacement. Okay. Then you build a decision tree using these k data points. Then choose the number of n trees of trees. So I want, suppose I want 10 trees or like 20 trees to be made. I want, so like for the same k data points, select k points from a training set, make a decision tree, do a prediction. Again for the next choose k data points, make a decision tree, and make a prediction. Right. So now for a new data point, make each of your entries to predict the category which the data points belongs to. Right. So now you have, like, suppose k value of k is 20. So now you have 20 trees, 20 decision trees. Now you want to predict, okay, if this is the feature, what should be the price? So for all of those 20 trees, you make the prediction. Okay, whether to buy this laptop or not, whether to buy this laptop or not for all those 20 trees, right? So finally, you use the voting model to select, okay, out of the 20 trees, 15 says yes, buy this laptop, 25 says no, don't buy this laptop, right? So final decision will be yes, I am going to buy this laptop, right? So I divide your data into k points, right? Or you can use sampling with replacements. It is completely up to your choice, right? Then I will make a decision tree for those k points. Then I will make a prediction based on like my any new data point that I want. Then I will repeat this with for each and for k times, right? Suppose for entry times. So I want to make 20 trees. So I will take, every time I will choose k data from my training set, make a decision tree, make a prediction. Then again I will choose another k points, some random sample k points, make a decision tree, then do a prediction, right? So this is one example. Microsoft Kinect uses random forest for motion and gesture sensing, right? Sorry for the forest has to be here and for has to be here. Okay, so it's a gesture-based gaming device which is made by Microsoft. It uses for random forest to predict what kind of gesture the player is making. Okay, so thank you for your time. I'll share next will be an implementation of decision trees and random forest both together in one Python file or one Jupyter notebook. Thank you. I'll see you in the next lecture.